Hello, today we're going to be looking at Unit 4, Lesson 1, Angles of Polygons. So we have a vocabulary word. Go ahead and refer to your vocabulary for the definition. And let's start off with a theorem. So Theorem 2.1, Polygon Internal Angle Sum Theorem. So this is going to be inside of the polygon. So the sum of the internal angle measure of the insided polygon is n minus 2 times 180. So whatever the number of angles are, we're going to subtract it by 2, multiply it by 180, and that's going to give us the total sum of the angles. So let's take a look at the first one. So find the internal angle sum of the polygon. So find the measure of each of the internal angles. So we have angle H, J, K, L, and M. So this is a 5-sided polygon, also known as a pentagon. So we're going to add up all the angles. So measure of angle H plus measure of angle J plus measure of angle K plus measure of angle L plus measure of angle M will give us that formula n minus 2 times 180. And as we said, n in this case is going to be 5 because this is a pentagon. So this is going to give us 5 minus 2 times 180, which is going to be 3 times 180, which is 540. So 540 degrees is what the sum of all these angles are. And all these angles, well, this is going to be 2x. This is 142. Angle K is also 2x. So H and K have the same angle. Angle L is going to be 3x plus 14. And angle M is also going to be 3x plus 14. So add all these up, 2x plus 3x plus 3x plus 2x. Well, that gives you a total of 10x plus 142 plus 14 is 170. So just copy that down one more time. 10x plus 170 equals 540. Now we can solve for x. So let's solve for x. So I'm going to subtract 170 from both sides. Gives me 10x equals 370. Divide by 10. X equals 37. So now I'm going to take that and put that in for each of them. Well, we already know J is 142. So 2 times 37, well, H is going to be 74 degrees. K, since it's the same thing, is also going to be 74 degrees. M and L have the same, so 3 times 37 plus 14 will give you 125. So this is 125 degrees. This is also 125 degrees. So we found the measure of each of the angles for that pyramid. Let's take a look at the next example. So we're going to look at example 3 next. We're going to skip example 2. And we want to identify the polygon given the internal angle measure. So what we're going to do is we're going to start off with what we have. So we have that it's 144. So 144 degrees. And then we don't know what it is. So it's going to be n minus 2 times 180. So distribute in the 180. So that gives you 144 n equals 180 n minus 360. I'm going to get n on one side. So I'm going to subtract away the 180 n minus 180 in. That gives me negative 36 n equals negative 360. So now what I'm going to do is I'm going to divide both sides by negative 36. And that'll tell me how many sides does this have? And it has 10 sides. So this polygon has 10 sides, known as a decagon. Think about it. Decagon is 10, so that's why this is known as a decagon, like decade. All right, let's take a look at our next example. Before we look at our next example, we have another theorem. So the sum of the exterior angles measures of the polygon, one angle of each vertex is 360 degrees. So measure of angle 1 plus measure of angle 2 plus measure of angle 3, 4, 5, and 6 gives you 360 degrees. So we want to find our missing values. So we want to find x. So I'm going to add all my sides up, and that adds up to 360. So this is going to give me 6x. So I'm going to start here. I'm going to work my way around. So 6x plus 9x plus 2x plus 139 equals, from the theorem, 360. Again, we're just solving for x, so I don't need to plug it back in. Add all these up. 6 plus 9 plus 2 gives me 17x plus 139 equals 360. Subtract 139 from both sides. That gives me 17x equals 221. Divide by 17. And I get x equals 13. And that's all we had to do because it said solve for x. Now, if we wanted, we could plug it in and find what is the angle measure for all of those, but we don't have to. And let's take a look at our last example, example 5. It says find the exterior angle measure of the polygon. So find the measure of each exterior angles of a regular dodecagon. So a dodecagon is a 12-sided figure. So this is going to give me 12n equals 360. Divide by 12. I get n equals 30. So just review through the different names of the polygons for this. Go ahead and summarize down here the two theorems we looked at, the interior angle theorem and the exterior angle theorem. Once you've summarized both of those, you're going to use the notes to help you solve the problems for today.